Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 219 of Leetcode, Stone Game 7. Wow, we're already up to 7. Too fast, too furious. Or which one was the 7? Let me know if you have a good pun on Stone Game 7. But anyway, so Stone Game, there's 7 of them, so hopefully by now you practice a little bit more. If not, that's okay. That's what I'm here for. But it is just dynamic programming, as you may have guessed. For me, just my thought process was that this was actually pretty straightforward. I have to go watch the video, but I actually solved this in about like 5 minutes. However, I did it with top down, and I can actually show that submission real quick. And I'm going to actually explain the top down solution, and then we could go over the bottoms up solution as well. But it's what the technical difficulties. Hang on. And then we'll go over the recurrence a little bit. Hopefully, if you have done the other 7 or the other 6 Stone games, you have the idea of what to do, right? So basically, the idea, and this is top down, which I think is easier to explain, though I did the steps a little bit weird. But basically, we have this idea of prefix sum. Why do we use prefix sum? Well, it's so that you can answer the query. You want to get the score between 2 numbers or 2 endpoints and get all the sum of all the numbers in between, right? Well, that's a perfect job for prefix sum. If you're not familiar with that, please practice it. It comes up all the time on Leetcode. Interviews, to be honest, probably not as much, but it does come up a lot in Leetcode and Stone games and stuff like that. So using this prefix sum, we're able to get these kind of queries in all of one time. So because if you do a loop from left to the right, then it's going to add an additional O of n, and that's going to be too slow. It turns out to be too slow anyway because Leetcode hates me, but that's another story. Okay, so then what is the recurrence after we are able to kind of get this score, right? Well, the recurrence then becomes very straightforward because, okay, you start with the entire array, which is 0 and n minus 1 inclusive, to be clear. And inclusive means that we want to be able to use 0 and n minus 1. So that means that we have go left right. I also had some issues with the base case, but actually you should return 0 in the base case because when you have one number left, one stone left, and you remove it, then there are no stones for you to gain points, and that actually cost me a couple of minutes as well. But okay, so now we set the best as just negative infinity as a sentinel value, it doesn't matter. And then now you could either take the left stone or the right stone, right? If you take the left stone, then your score is just the entire, and actually you might actually not need, now that I think about it for a second, you actually don't need the prefix sum if you just keep the total and then subtract that from the total in a running kind of way. But maybe that's messy. So this is a little bit easier, but you might not need it per se. But in any case, yeah, so what happens when you remove the left stone, right? Well, the score that you get is just the total score of, the sum between left plus 1 to right, which is what we have here. And then we recursively subtract it from the score because that's the score that Bob is going to get, or your opponent is going to get. And that's the negative score because we want to subtract it. I should have written it the other way, but you still get the idea. And then the other move that you can do is removing the rightmost stone. And when you remove the rightmost stone, your score, of course, is the entire array except for the rightmost stone that you just removed. And then Bob now gets to play that sub game. So that's basically the entire problem. However, I don't know why, as I said, this actually leads to time limit exceeded. However, this is n squared and I don't think you could do faster. So I was like, what is going on? So basically I rewrote it bottoms up. I also debated during the contest to rewrite it in Java, but I don't know. I think, to be honest, I think Python just got screwed, or at least I got screwed a little bit, if other people passed using the recursion. But yeah, and this is basically the same idea as the top-down recursion with memorization. It's just that I converted it to bottoms up. This is not as easy as the another one. The tricky thing to note is just to make sure that you have the order in the right place, because note that the for loop, in the inner loop, I go actually from right going in, or from right going out. The reason why I keep this is because that what I want to do is start with left and right, as close to each other as possible, and then propagate out. That's kind of the idea. I know it's a little hand wavy. Converting between this bottom up, from top down to bottoms up, is not always easy. And after the contest, I'll see whether, whether that's necessary. I really don't know why I got time limit for essentially the same thing, so I'm a little bit sad about that. Because n is only 1,000, it's not even a big number, so n squared should be way fast. So I'm a little bit disappointed that it cost me about 8 minutes, like probably 5 minutes coding, 5 additional minutes coding, and the wrong answers, so like 10 minutes in penalty in total. So that's a little bit sad. But yeah, that's all I have for this problem. Except for that, every time I say that, I always forget to go over the complexity. So because of this is dynamic programming. This is a matrix. It's an n by n matrix. It's going to be O of n squared space. Here, the O of n loops on O of n loops. So it's going to be O of n squared time. That's all I have for this problem. You can watch me solve it live during the contest and watch me be sad during the contest. And I will... Oh yeah, you can just keep on waiting. Doo-doo. That's not right. Why? Oh, this is not it. This is 0 because there's no stones left. Dumb. Really? That's actually surprising. Given that it's only 1,000. This is so fast. This is one of those like Python is getting screwed kind of problem, it seems like. Because this is just n square for 1,000. Really should not be 68. I'm wasting so much time on this. This is silly. I mean, it's not fast, but it's not slow, so this is... I don't know that I got the order quite correct, to be honest. So we'll see. What am I doing wrong? What a mess. No, this is right. Did I go out of bounds? Oh. Just being dumb. It's not even that much faster, and of course my answer's wrong, but is this right? I actually don't remember. It's faster, but is it fast enough? If I have to switch languages, I'm not going to be as happy. Really? It's still too slow? Oh, what a stupid problem. Yeah, thanks for watching. Let me know what you think about today's problem, and just let me know what you think. Hit the like button, smash that subscribe button, join me on Discord more so you can chat with me and people and ask questions. And I will see y'all next contest, next problem, whatever. Bye bye.